we're going to be solving compound and absolute value inequalities. Now this is a takeoff of what we did Friday. And so first of all, we're going to talk about a compound inequality. And this is taken from your book. A compound inequality is two inequalities that are joined by the word and or the word or. So two inequalities joined by the word and or the word or. Now this is taken off of page 41, so you can follow along there if you want to. And the thing at the bottom of the slide says the graph of a compound inequality containing and is the intersection of the solution sets of the two inequalities. Now this isn't going to make a whole lot of sense now until we look at a few examples, but remember that when we use the word and, it means intersection. Now when we use the word or, it's going to mean something different. So what we're going to do is we're going to go ahead and look at one of the diagrams from your book. And this is and compound inequalities. And if you notice, it says a compound inequality containing the word and is true if and only if both inequalities are true. So basically, when you think of the word and, you have to think both. The and means both. And so in here, x is greater than or equal to -4. We've graphed that in the top line. In the middle line, we've graphed x is less than 3. And then our final solution will be all numbers that are in both. Okay? And so that's where our solution set comes from. So here's another way that we can write an and inequality. And if you look up there, it says solve 8 is less than 3y minus 7 is less than or equal to 23. And so what we're going to do is we're going to go ahead and go ahead and solve that. Now how we solve that is we're going to isolate everything in the middle so that there's nothing more than y. So how do I get rid of, I'm going to add 7 to both. Now normally it would be both sides, but in this case it's 3. So notice we have 3 parts to the inequality. We have a left, we have a middle, and we have a right. And so I'm going to add 7 to all those parts. And on the left side, I have 8 plus 7, which is 15, is less than 3y, which is less than or equal to 30. Now, how do I get rid of everything so that y is the only thing left? Divide by 3. So I'm going to divide the middle by 3, the left by 3, and the right by 3. And I'm left with
5 is less than y.
5 is less than y, which is less than or equal to 10. Now this is actually a compound inequality. Okay, we could write this inequality with the word and. So remember, and means it has to be in both. But the nice thing about this is it already tells us what numbers we're using. And so what two numbers are we going to use in our solution? 5 and 10. Very good. And so let's see again what that means. It says 5 is less than y. So what type of circle do you think I should put on 5? An open? Okay, good. I'm going to put an open there because it is not equal to. What type of circle am I going to put on 10? Closed. So there is my circles. Now for and, remember it's got to be in both. I'm going to shade everything in between. And that is my solution set. So if you were doing this on your homework, 2 things I'm looking for. I'm looking for this right here. Okay, and then I'm looking for the number line. So you need to have both of those things. Let's go ahead and look at another one. -5 is greater than or equal to 3x minus 2, which is greater than -14. Now this is written in a little different way because all of the inequality signs are turned the other direction. What's the very first thing you're going to do? Add 2. Good. So I'm going to add 2 here. Here, here. So what do I get? -3 is greater than or equal to 3x, which is greater than -12. What do you do now? Divide by 3. So on the left, what do I get? -1 is greater than x, which is, greater than or equal to x, which is greater than? -4, good. So now, I'm gonna go ahead and label my number line. What do I do to graph this?
Um, On -1, there's an
Mhm.
open circle.
On -1, there's a what circle?
Closed circle.
Okay, on -1, there's a closed circle.
I meant closed.
Okay,
And on -4, there's an open.
and on -4, there's an open circle.
And shade between.
And I'm gonna shade in between them, good. And that is your solution set. So once again, things I'm looking for this, and then I'm looking for the number line. Any questions on those? Think you can handle that so far? All right, let's go ahead and look at the next one. Now we're gonna look at OR. Now the graph of a compound inequality containing OR is the union of the solution sets of the two inequalities. So let's look here at our diagram below, okay? With OR, all it needs to be done is shaded once in order for it to be included. So it just has to be shaded. So if you look at the top one, I've shaded the right arrow. The middle one, I've shaded the left arrow. So the solution set of my OR statement will have both of those included. So we're gonna look at a few of those. It says solve k plus 6 is less than -4, or 3k is greater than or equal to 14. Graph the solution set. So we've got two very simple inequalities that we're gonna solve. The first one is k plus 6 is less than -4. The next one I've got is 3k is greater than or equal to 14. So how do I solve the first one? I what? Subtract 6, good. So I get k to be less than -10. Okay, so here we go, -10, -9, -8, -7. So I'm gonna go ahead and number. Now, if I was going to graph the solution set to that, what would I do? Open circle where? On -10, and I'm gonna shade which way? To the left. So now what I'm gonna do is I'm going to do the second inequality. I'm gonna graph that one in pink. And so now I have to solve 3k is greater than or equal to 14, so what do? Divide by 3. And so some people were like, whoa, that doesn't come out even. Well, yeah, so you can graph fractionals. And so this is actually 4 and how many thirds?
2.
2/3. So what type of circle am I going to put at 4 and 2/3?
Open, they're closed.
A closed circle, and I'm going to put it just about 2/3 of the way there. And which way am I going to shade if it is greater than 4 and 2/3? To the right. So that is what that one looks like. So then now what I need to do for my solution set is I need to combine both of those into one final inequality. Now how I combine both of those is it just needs to be shaded in one. So if I start working left to right, is the left arrow shaded on at least one? Yeah. Oops, just a second, forgot to grab my pen, there we go. The left arrow is shaded in blue. Okay, where do I stop? -10, I'm gonna use an open circle. Is -9 shaded? -8? -6? When is the next thing that'll be shaded? 5. Well, 4 and 2/3, and I'm just gonna go ahead and put a closed circle, and then I'm gonna shade that in. So our solution set is what's in orange. If I was going to answer that in words, here you go. This is my solution set. So, in the orange box and the orange line, yes, you need to have both.
No, do we have to have both of the,
No.
the blue and the pink?
Nope. The question is, do you need to have the blue number line and the pink number line? No. But it should help you see your solution set. So let's go and look at another one real quick. 5x is greater than or equal to 15, or -3x is greater than or equal to 21. So what's the first thing I do? Divide by 5. So I get x to be greater than or equal to 3, or. Okay, so let's go ahead and graph the x is greater than or equal to 3. So 0, 1, 2, 3. next circle on 3? Closed. Which way am I gonna shade?
To the right.
To the right. So the first one I'm gonna do, there you go.
Could be like south.
Okay, let's solve the next one. What do you do on the next one? Divide by -3. So x is less than or equal to -7. Why did I flip the inequality, guys? Because it's a negative. Yep, you divided by a negative. So now I'm going to put a closed circle on -7. And which way am I going to shade?
To the right.
I'm going to shade to the what?
Left.
To the left.
To the north.
Okay, so now my final answer, first of all, is going to include this right here. And then it's going to include the solution set of both. So solution set, I know first of all I'm going to have a closed circle here and a closed circle there. And I'm going to go ahead and shade. Okay. I'm going to go ahead and shade to the right. And I'm going to shade to the left. So that is your solution for that. Questions? Okay. The next thing we're going to look at are absolute value inequalities, GOLA. And so you need to go ahead and get that down. I'm going to go ahead and stop because I think I'm probably running close to time. And I'm going to restart the video on the second example.